I would like you all to go on your graphing calculators right now, please, and to enter in this equation. H of t equals negative 2t plus 12. So the context behind this is a candle manufacturer found their long-last candles melted according to this formula. H is the height of our candle, and t is hours. So we all should be graphing this in our graphing calculators right now. Make sure you're putting negative 2t plus 12. Check your window settings to make sure that they're appropriate. Depending what you did last, it could be incredibly far off. It might be okay. And then you're going to press graph. It's in your notebook on question 1. Depending on your window settings. So go back to your equation. Did you not put in a variable? Or you might have to zoom in a lot. So you should get a graph that's a downward angle of approximately this. Let's pause for a second. We're just going to chat for a second about this equation. So we have a candle. Let's all visualize a candle in our mind. Candles, as they burn, shrink in height, correct? Yeah. Right? The wax melts, goes off into the air. It's great for our lungs. From here, it makes sense that my graph goes down, right? It's because my candle should get shorter over time. Our graph in our calculator still does not include the context. Can I have a negative height to a candle? No. Can I have negative time? No. So that's why, like in your notebook, the sketch is only of our positive or quadrant 1 on our Cartesian plane, because that's the only one within the context that makes sense. The graphing calculator, you have to be smarter than it. On your graphing calculator, actually coming back to the equation, so the negative 2, what that's getting at is that it's actually shrinking 2 centimeters per hour. So that's why it's negative 2. It's important that you guys are recognizing the meaning behind this equation. Our next unit, we spend a lot of time on it, but you should start understanding where these equations are coming from. What could that plus 12 mean? Like, why would it be 12 and not 14 or not 16 or 22? What else about the scenario could that be coming to? No idea. That's going to be the height of our candle. So you guys are all doing physics right now in science. When I have a speed, which is centimeters per hour, times time, speed times time gives us what? Distance. So that's how much it's shrinking overall, distance. Okay, in your calculators, determine the value of h at 5. So in your calculator, this is from your trace menu. You're going to 1 value, and we're just going to enter in x equals 5. So second trace, 1, x equals 5. We get an answer of 2. Were we all able to do that? Angelica, do you have your calculator here? I have a charger with me. If you want to go grab it, then I can charge it. Or you can charge it. What does that mean? What's the meaning behind that? Go ahead, Carissa. Good. For how long? For 5. Good. Right on. So the height of our candle. So these questions, you have to relate back to the context. We want to know that you can actually interpret the math, okay? Evaluate the following and explain the significance of each. So x equals 0. So you can plug this into your calculator or you could do it algebraically. This question does not specify. So whichever your heart desires. I will specify how I want you to solve it at times. You have to be able to do it algebraically and you have to be able to use your calculator. So just as a review, if we were doing it algebraically, I would do -2 times 0 plus 12. So my answer then is just 12. So that point is our y-intercept at 0 and 12, which is the height of our, like the starting height of our candle. H at 6. I want you to try that one on your own. So on your calculator, second trace to value, we're plugging in 6, and we get 0. So what does that mean? Go ahead, Mateo.
-2 times 6 is -12.
But you're totally right. You're totally right. But what's the meaning behind it? Not like, how did I do it?
It's already burnt out.
Good, right on. So there's no candle left. So after 6 hours, I kind of have issues with this because if you burn a candle, do you ever get it down to 0 centimeters? No, right? Like candles burn into like a bowl type shape, right? Because of just how the candle wick causes it to melt. You're like, is that really 0? But theoretically, I guess you could. H at 8, when we plug in 8 here, we get -4. Can I have a negative height of a candle? No. So there will be questions like this, and your answer is there's no meaning. You cannot have a negative candle height. It exists because we're using an equation, but you have to be smarter than your equation. Question E, how long will it take for the candle to burn to a height of 7? So it's basically saying if y is equal to 7, what is x? So this is where in your calculator you have to put in that second equation. So in your calculator, you're going to go to y equals, do a second line at 7. Because that's going to give us all of our y points at 7. So then if you press graph, we're going to get this nice horizontal line that's going to pop up. And if you do second trace, and you're going to go down to intersect. So we want to find where those two lines cross. We know they're going to cross at 7, but we don't know the x value with it. Generally speaking with this, your little cursor is going to plop up fairly close. It just has to be close to where they cross. So enter, enter, enter. I don't have it.
Oh, I have it.
Oh, that works too. So at 2.5. No, but you can plug it into your computer. I don't know if your computer has to be charging as well or not. I feel like it could be.
I have my phone that has like one of the where you can like plug in that.
Like into the wall.
Yeah.
Oh, you could do that. So we should find it's 2.5 hours that our candle will burn down to a height of 5. Suggest an appropriate domain and range for this function. So our domain is our time in this case. So all of our time such that time only exists from 0 hours of burning this candle all the way to 6 hours, right? 6 hours. Within that, it's every second possible, so it's an element of the reals. If you wanted to use X there, you could totally use X as well. Our range, so our height of our candle, varies from 0 centimeters tall all the way to 12 centimeters tall. So that's it for this question. I just want to pause for a second and say something that I don't think I've said explicitly enough. Say we were talking about people and whatever it is. So people, number of people, so number of guests was our x-axis. You can't have a part of a person, right? So it would be like if I had a graph that was like with dots all the way up like this, but lots of them, that's discrete data. With discrete data for a domain and range, you have to list out the points. But if you have a lot of points, sometimes you can still use this notation. So in this case, like say we're talking about the number of people, you could say like if there was up to 100 people coming to your party, you can't have a partial person, but you could say it's an element of whole numbers. W being for whole. A whole number has no decimal places. So it's telling you right away, it's every single number, 0 to 100, but I'm allowing myself to be kind of lazy and not writing out 0, 1, 2, 3, 4, all the way up to 100. You could do that including like natural numbers if you wanted to like not include 0 at that. So you can put like your other real natural integers in place. So you still could use this general notation, but to kind of restrict it. That's if your discrete data has like a lot of discrete data. So that's something else that like comes up that I feel like I haven't explicitly told you very well. So that's it for this lesson. Pretty short and brief. All I want you to do is numbers 1 and 4 from here. That said, I think you guys have a lot of outstanding questions to do from prior lessons. Like I don't think you're all up to date. So I want to give you a little bit more class time today to make sure you're all caught up. So that way next week you can just review everything together. Okay, go ahead, Gavin.